Somewhere in the void of interstellar space, an invisible mass the size of Jupiter is hurtling forward at 100,000 miles per hour. These are rogue planets. Unlike Earth, these worlds are completely untethered from any parent star, drifting perpetually through the galaxy in total darkness. Current astronomical surveys estimate that the Milky Way contains billions of these starless worlds, suggesting that rogue planets may actually outnumber the stars in our galaxy. The universe is a chaotic environment, populated by invisible planetary mass projectiles moving at interstellar speeds. To detect these hidden threats, astronomers use a method called gravitational microlensing. When a massive, unseen object drifts in front of a background star, its gravity acts like a lens, bending and magnifying the light we see from Earth. We are currently building massive next-generation infrastructure, like the European Southern Observatory's extremely large telescope, to track these cold, fast-moving objects. Imagine a super-Jupiter rogue planet entering the weak capture region of our solar system. This boundary is governed by fractal gravitational poles, similar to a Mandelbrot set, where the combined influence of the Sun and the Milky Way can permanently trap a passing world into a heliocentric orbit. Because this intruder emits no light and travels at immense speeds, it could easily slip past our early warning systems until it's entirely too late to respond. As the rogue planet smashes the Kuiper Belt, gravity violently ejects asteroids into interstellar space. We see evidence of this chaos in the sednoid alignment. Converging orbits of distant dwarf planets suggest a rogue planet previously passed through our system. If a new rogue planet approaches from directly behind the Sun, our ground-based telescopes would be completely blinded by solar glare. Our only warning would come from solar observatory satellites. This SOHO coronagraph image, tracking the tiny box labeled 500th comet, shows how small our visual warning window is near the Sun. Humanity would have just 3 to 4 days before impact. The apocalypse wouldn't be a years-long global effort. It would be a sudden realization, arriving just hours before the end. As the rogue planet approaches, its gravitational tidal forces begin tearing through the crust, triggering global megathrust earthquakes and world-swallowing tsunamis. Moments before the physical collision, the two atmospheres slam together, creating a wall of superheated plasma that incinerates the sky. The impact transfers trillions of megatons of kinetic energy, a force that instantly vaporizes the oceans and peels back the Earth's crust. Survival is impossible. The sheer heat of this energy transfer would bake through to the deepest subterranean bunkers, erasing all biology instantly. The kinetic energy of the collision forces an immediate phase change. The rocky mantles of both worlds vaporize on contact, creating a single homogenized cloud of rock gas. This creates a synestia, a giant, glowing, rapidly spinning donut of vaporized rock and plasma. This new object faces a critical physical limitation. The collision has injected so much rotational energy into the system that the vapor cannot condense back into a stable, solid planet. Earth is no longer a world. It is a volatile cosmic cloud trapped in a state of phase change. To stabilize, the system must enter the evection resonance, a gravitational interaction with the Sun that acts as a brake on the system's rotation. These 4 phase space plots illustrate the resonance mechanism. Concentric contours map the system, transferring dangerous rotational energy outward into its orbit. As shown in plot D, the extreme energy distribution bleeds momentum to finally condense. Without this resonance, a vaporized world could never stabilize. This exact sequence of destruction and resonance is the history of our own planet. 4.5 billion years ago, a rogue impactor called Theia smashed into the primordial Earth, triggering this exact chain of events to birth our moon. That ancient collision provided the specific axial tilt and rotational period required for Earth to stabilize its climate and support life. While a rogue planet could erase us in an instant, on the grand timeline of the universe, utter destruction is the prerequisite for creation.